numbers, you know that exponential j beta x, it will be cosine plus j sine. And for minus, it will be cosine minus j sine. When we substitute and simplify, we'll find there is cosine and sine with two constants. So we will write the final answer. Y equal exponential, the real part of the root times x multiplied by constant cosine beta x plus constant sine beta x. Now let me summarize the discussion here for homogeneous differential equation. Homogeneous differential equation came in this form: a y double dash b y dash plus c y equals 0. A, b, c, d are real numbers. Now let's assume y is exponential mx. So let me find y dash and y double dash. I got it. Y dash, it will be m exponential, and y double dash m square exponential. If I substitute here and here and here by them, I will have this expression. Now divide by exponential, because or let me say cancel it from all parts. Now we have the auxiliary equation. As I told you, from where it came from here. This is the auxiliary equation. Now auxiliary equation, let's take different cases. The first case, okay, here, real m1 and m2, as you can see here, and the general solution will be, as I mentioned, constant exponential the first root plus constant exponential the second root by x. Example, have a look. Y double dash minus y equals 0. I will take this one or let me convert, sorry. I convert m square minus 1 because y dash is not here. It's cancelled already. So I take it to the other side, will be 1. I take the square root, will be plus 1 minus 1. So two real but different. Directly I will say, okay, the solution is c1 exponential the first one times x first root plus c2 exponential the second root times x. Now what if, in case 2, what if they are real but equal? Okay, the same. Okay, now the answer is, as I mentioned, either write it c1 plus c2x exponential mx, or open the bracket exponential multiplied by constant and constant x exponential. Let's see this example. Now from here, y double dash minus 2y dash plus y equals 0. I wrote the characteristic or the auxiliary equation, m square minus 2m plus 1 equals 0. I solve it, I got equal real roots. So I will write the answer according to the formula which I know already. I know the formula, just substitute for m by its value, which is 1. Now, case number 3, when we have complex, as you can see here, complex roots, alpha plus minus j beta, okay? Then I will write the final answer to be exponential, the real part, constant sine beta x plus constant sine beta x. Now let's take example. See here, y double dash plus 2y dash plus 5y equals 0. Now write the characteristic equation, m square 2m plus 5 equals 0. Use quadratic formula. Quadratic formula. I go with the roots, minus, plus, minus, 2i or j, whatever. Now this is alpha, as you can see here. This is alpha, and this is beta. Okay, 2 is beta. Now I can write the final answer is minus x, which is alpha, is minus 1. Sine beta is 2x, cosine 2x. That's it. Let's take more examples with initial condition. Have a look. Now this is my equation. I wrote it in this way: m square, the characteristic or the auxiliary, m minus 2 equals 0. Or sometimes they use lambda square plus lambda minus 2 equals 0. I solve it by factorization, quadratic formula. I got minus 1 and minus 2. You will directly say, okay, this is real but not equal. Correct? We write the final answer. C1 exponential, the first root, which is 1x, plus C2 exponential, the second root, which is minus 2x. He gave me here initial condition. Okay? I will use the first one here directly because I need to substitute for y by 4 and x by 0. But to use the second one, I need to differentiate y. I will differentiate and substitute. As you can see here, I substituted 0. I got equation. Now I differentiate. As you can see here, this one it will be c exponential, and this one it will be minus 2c exponential. I substituted here, as you can see here, 0, it will find to be minus 5, so I have another equation. Solve these two equations simultaneously, you get c1 and c2. So back and substitute for the constant, you have final shape of the waveform, sorry, of the formula or equation. Another example, here this one it will be m square minus 4m plus 4 equals 0, or lambda, as you can see here. I solve it, I go to 2 and 2, which represent real equal. So directly I will see constant plus constant x exponential 2x. Now again I have initial condition for y and y dash. As I did in the previous example, I differentiate to find y dash exponential to be multiplied here and here. With this one it will be directly exponential, okay? And here, as you can see here, sorry, here exponential x, and there is x, so it's u v equal u dash v plus v u dash. We simplify, we got this expression. Now I will substitute by the initial condition for y and for y dash. I got directly from the first one c1. If I substitute the second equation, I got c2. So I have c1 and c2. Now back to the original equation and substitute. One more example here. Have a look. Here, as you can see here, y double dash lambda square or m square, 0.2 m or lambda, 4.01, as you can see here. I solve it by quadratic formula. I got lambda equal minus 0.1 plus minus 2. So this is alpha and this is beta. I write directly the solution exponential alpha x multiplied by brackets a cosine beta x plus b sine beta x. Again, he gave me initial condition for y and y dash. Again, I need to differentiate to find y dash. So differentiation of this part, this is u and this is v, all this is v. So when I differentiate them, I got this expression. I substituted for the initial condition to find a and b, and back to substitute in the original equation here to find the final y. Now I advise you to spend some time solving these let me say exercises. You need to practice. With more practice you will learn more, and we will take more examples in the next session. See you. Bye bye.